We'll look at question 3 of practice now 4. The first 4 figures of a sequence are as shown. This sequence is called the triangular number sequence because each term consists of equally spaced dots in a triangle. We have to first draw the next 2 figures of the sequence. So you should get something like this for figure 5 and figure 6. Figure 5 should have, if you were to count the number of dots, it should have 5 at the bottom. And if you see it from the left hand side, it will also have 5 dots. Same for figure 6, 6 each, with 1 overlapping. Let's look at part 2 now. Part 2 wants us to copy and complete the table below. So we can use the pattern in question 2 to help us a little bit. That was the question that we have done previously. So for the first figure, number of dots at the base of the triangle is 1. Okay, so it will increase as it increases. So let me fill this in. So the base will have 5, 6. For n, it will be n. Okay, and the number of dots, so we have to add up. So for the first triangle, it's just 1. For the second one, second figure, it will be 1 plus 2. So it's something like this. 1 plus 2. And then 1 plus 2 plus 3. And then 1 plus 2 plus 3 plus 4. Okay, so we have to actually see how this table guides us to find the total number of dots for figure 5 and 6 and ultimately for n. So let's fill that in. So for the first one, it's just 1. Okay, and how did we get this? Okay, we have to refer to the previous question to help us. So for question 2, we actually have 1 times 2 to get 2, 2 times 3 to get 6, 3 times 4 to get 12, 4 times 5 to get 20. And then we see that the number of dots for question 3, okay, for the first term, you have 1 dot, then you have 3 dots, then you have 6 dots, then you have 10 dots. So we do see that there's something that can help us. Okay, so it would be the value divided by 2, the value divided by 2, and so on and so forth. So coming back here, it will be 1 times 2 divided by 2. Then it's 2 times 3 divided by 2. Then it's 3 times 4 divided by 2. Then it's 4 times 5 divided by 2. So we do see a pattern as well. So let's try to fill in the pattern for 5, 6, and for n. So the number of dots would be 1 plus 2 plus 3 plus 4 plus 5. That will give me 15. And I actually get that from 5 times 6 divided by 2. So if I were to fill in for 6, it will be faster if I were to fill the last part in. Is 6 times 7 divided by 2. So I know that I have 21 dots. If I go on to n, it will be n times n plus 1 divided by 2 to give me the total number of dots. So let's simplify this. Okay, I will do it over here. N times n plus 1 over 2 would be n squared plus n over 2. So this will be my total number of dots. Let's look at part 3. We need to find the total number of dots needed to form a triangle with a base that has 100 dots. So basically, we are trying to find Tn. I'll do part 3 here. So T 100. Okay, because that would actually form 100 dots at the base. So T100 is 100 times 101 over 2 dots. So this will give me 5050 dots. So I will need a total of 5050 dots to form a triangle with a base that has 100 dots. For part 4, will there be a figure with 9999 dots? So I have to now fit this into my equation. So 9999 will be equals to n times n plus 1 over 2. So let's simplify this. So I will get this. So I want n times n plus 1 to be 19998. So it's similar to what I have done in question 2 of practice now 4. I will try to find possible values of n such that it can fit in. So I will take square root of this. It's 141.41 blah blah blah. Okay, so I'm going to try. What if I have 141 times 142? 141 times 142 gives me a number that is bigger. So I will try and see if I can get a smaller value then. How about 140 and 141? And I get this amount of dots. Okay, so I see that 19998 dots cannot fit in based on these 2 tries that I have tried. So my conclusion would be there will not be any figures with 9999 dots. And I write my concluding statement. So this will be for question number 3 of practice now 4. It's not that simple because I have to actually make use of question 2, the previous question, to help me with this table here. Okay, but do remember that what I'm trying to do is to establish a relationship so that we can generalize for n.